Hey viewers, today I'm going to do a little experiment with a selected number of fans, or what used to be fans. As you can tell, none of them have got blades anymore. Before you go flaming and spamming me in the comments, so you wreck these good fans, I could have used them, what's the matter with you? On the guide it's got over 1,000 of them, so give me a break. And no one else is going to do these experiments, so I might as well do it just out of curiosity. What I'm going to do is find out what these DC brushless fan motors are capable of doing for RPMs. I mean, some of them are pretty damn fast when they're pushing air. Like, let's see. Oh, this little San Ace 40 here is rated 14,800, and that's when it's pushing air. What the hell is it going to do when it's not under any load? So that's what I'm going to do today, and I'm going to find out. And I'm going to overvolt these until each one of them does die, but I'm going to get their RPM reading with my tachometer, and I'm going to increase the voltage with a newly acquired 10 amp Variac. So yeah, and I'll even monitor their voltage with my multimeter. So I'll set that up and we'll find out what these things are capable of doing. Okay, first up is the Oriental Computers fan. When it had blades on it, it would do 2,410 at 0.45 amps. So let's see what it will do at 12 volts with no fan blades on it at all. About 3,400. So only about 1,000 RPMs different. But let's start cranking the voltage up and see what it can really do. The bearings are kind of noisy in this as well. That's over 5,000. $6,000. So there we go, with 6,100 at 20 volts. Let's see if we can get up to 24. .24 volts, up to 7,400 RPMs. That's not bad. Let's see. Can reach 28 volts. There's 28 volts. Doesn't like 33 volts. Well, let's keep cranking it, see what happens. Woo! Nice. Next up is the top motor fan. With a head fan blades at 2,600 at 0.2 amps. See what it does without blades. Let's see, about 3,800, and it's speeding up a little bit. It'll probably hit about 4,000 and 12.16 volts. And there's 4,000. So let's crank it up a little bit, see what we can do with it. Kind of sounds like a quiet air raid siren or something. Oh geez, that just jumped up quite a bit. There's 9,000. 10,000. Oh, is that it? It's not even gonna pop, is it? Well, that blows. On to the next. Next up is the little TNT fan. I don't know what it did before I took the blades off it, but it was just a crappy little thing I picked up one day and didn't even bother with it. So but it's pretty fast at 12 volts. 12,000 RPMs, 12 volts. He's really going. 20,000 RPMs. Jeez, 24,000 RPMs at 30 volts. How much more can it take? Oh, that's about it, 25,000. Or not. No, still going. Ah, I spoke too soon. Spoke too soon. And that's the end of that one. Next up is this NMB. It's already damaged somewhat, so it only reaches the speed of 2,600, which it would normally do 3,600. So we'll see what a damaged one can do. And as see, it doesn't always start on its own. That's why it's damaged. Now 6,200 at about 13, get it closer to 12 volts. Probably about 5,800 at 12 volts, but I can't quite get it there with this variac. But let's crank it up, see what it can really do. So 25 volts, 11,090 RPMs. Oh. Well, that's the end of that one. Oh, is that it? Oh well, on to the next. Next up is this smaller NMB. It's still 120 mil, but it's not as thick. Top speed 2,500 with when it had blades. Oh, 5,000 without at 12 volts. Doesn't sound very healthy. Something's cooking. Oh, and that's it. On to the next. Next up is this 90 mil NMB. When it had blades, it was rated at 4,100 RPMs. Alright, here we go, 12 volts. So about 5,600. Wonder if this will do any better than this two large or 120 mil NMBs did. There's 24 volts, 10,000 RPMs. I hear something cooking. It's unhappy. The fan's drawing 2 amps right now, so it's not doing so well. Whatever cooked wasn't critical to keeping it going in the right direction or at a high speed. Oh, and there it goes. That's it. Alright, on to the next. Next up is this 90 mil Delta. Rated speed with blades was 4,800. See if it does any better than that NMB did. Okay, here's a delta 12 volts. That's pretty good for just 12, 9,400. I had to put a little bit of tape on the smooth part there. It was vibrating quite a bit without the blades. It became unbalanced. It got so bad. This is actually my second take on this video clip for the Delta. By the time I got to 20 volts, it was just shaking so bad I had to stop. Sounds way better now. So 20 volts, 15,000 RPMs. Wow, 24 volts, 18,000 RPMs. That's pretty damn good. This is about the speed a vacuum motor does. Of course, when you take the impellers off a vacuum motor and you let it rev up with no load, it'll do 35 to 45,000. But when it's actually sucking air, they do about 20 to 28,000. Oh, this Delta just doesn't want to die. Oh. It's drawing 6 amps right now. 9 amps. Ah. It's cooked. Well, that was impressive. Okay, here's a Delta 12 volts. That's pretty good for just 12, 9,400. I had to put a little bit of tape on the smooth part there. It was vibrating quite a bit without the blades. It became unbalanced. It got so bad. This is actually my second take on this video clip for the Delta. By the time I got to 20 volts, it was just shaking so bad I had to stop. Sounds way better now. So 20 volts, 15,000 RPMs. Wow, 24 volts, 18,000 RPMs. That's pretty damn good. This is about the speed a vacuum motor does. Of course, when you take the impellers off a vacuum motor and you let it rev up with no load, it'll do 35 to 45,000. But when it's actually sucking air, they do about 20 to 28,000. Oh, this delta just doesn't want to die. Oh. It's drawing 6 amps right now. 9 amps. Oh. It's cooked. Well, that was impressive. Next up was this Nidec Beta V. 0.58 amps. When I had blades, it was rated at 6,700. So this little fan should really go, as long as it doesn't give out. Alright, here's the Nidec at 12 volts. By the way, this is a 60 mil. So 9600 at 12 volts. Let's crank it up. I wonder if it'll get anywhere near that delta did. $20 volts, 17,000 RPMs. There you go, 20,000 RPMs. The fan's only drawn about 0.59 amps, so it's actually still within its spec. $26,000. $27,000. Wow. Impressive. Oh, I hear something cooking inside. Oh, wow. Just got a big jump. 30,000? Holy shit. Ah. Woohoo. That was a good one. Jeez, that was up to a little over 30,000 RPMs. Next up is this Delta. Here's one I tore apart some time ago. I know for a fact it does about 15,000 when it hit blades. So we'll see what it does without. Alright, here's a little Delta. I had to put something to cushion the vibrations from this. They were just, the frequency of it was just so high, it was getting too noisy. So I put it under that and just didn't even bother hooking up to the piece of metal. So anyway, here we go. It's got a lot of starting torque. Moved on me there. So there you go. Gotta make sure my meter reads it right. There, 32,000. Holy crap. Oh, come on, don't die yet. You're at 46,000. $50,000. Holy shit. Holy crap. Now it's getting a boost. Okay, this is officially the fastest thing I've got. As long as it doesn't die. It was previously a vacuum motor. Unloaded, it did 55,500. Jesus Christ, this thing's insane! Ah. That was incredible. I never expected it to ever go that fast. And that's the end of that. I'm amazed. Next is the SanAce 40. When I had blades, it was 14,800 RPMs. Wonder if this will do as good as the little Delta did. Alright, SanAce is ready to go. Let's see what it can do at 12 volts. About 28,400. Your 40,000 at 16.5 volts. And it doesn't really seem to want to go any faster than that. Yeah, any higher voltage in it just stops. Still drawing 1.7 amps. And I can see smoke brown out of it. Well, that's the end of that one. Oh, cool effect on the smoke there. It's kind of hugging the cloth a little bit. That's neat. Next up is the Infotech dual fan. I'm going to separate them and do them individually, because I can't get RPM readings of both at the same time. I've only got one tachometer. Alright, this is the first half of the Infotech fan. With blades it would do about 15,500. So 27,200. $38,000. 42 at 18.7 volts. I think this will do better than the SanAce one did. $50,000. I think it's reached its limit right there. Yep. It just went completely open circuit. Alright, this is the back half of the Invitech fan. This one with blades would do about 11,500. So 20,700, 12 volts. Oh, wow, that didn't go very far. No amps, it's gone open circuit. Oh well. Next up is this blower fan. With blades, they would do about 5,500. As you can see, there's quite a bit of circuitry on these things just to make them spin. Alright, the blower star fan is ready, and if I remember correctly, these are actually NMB motors, so we'll see how it does. It's about 8,400. At 20.8 volts. It's actually doing pretty good. Oh, something's starting to overheat. I can hear it. There you go, 20,000 RPM. Drawing 1.4 amps. That actually went pretty good. A little bit of smoke coming off it there. Better than I thought it would do. Last up is this APW blower style fan. 12.5 volts. 5,400 RPMs when I had blades. Amps 1.4. This is actually quite off balance when all the plastic and stuff's off it. You can see some of the holes are larger as I've tried to balance this thing out a little bit, and it still vibrates a fair amount, so it might get kind of noisy. Alright, 12 volts. And 6,200. It's only drawn 0.4 amps. 20 volts, 10,500. I wonder when that little capacitor on there will blow. I wonder if that's a voltage protection. Still drawing 0.3 amps. It sounds like it tried to restart. I'll cut power to it and turn it back on, see if it actually does restart. Nope. It's toast. Well, that's the last of them, folks. Thanks for watching.